Okay, we are now recording. So welcome to our April Fool's engineering class. Oh, I see. So a J-pole antenna is an antenna that looks like a J. Well, that is very enlightening. Thank you, Brian. I'm glad you enlightened us all there. Okay. All right, let's not worry about the J-pole antenna. Class has started. I've started the recording, so let's get going. Okay. So everybody, please don't forget what I told you last time. Because of the way that we need to run the class now, we can't do all the hands-on stuff that we did before. So a lot more of your grade is going to be based on what you turn in, the assignments you turn in. And I can't let people turn in too many late assignments because then you fall behind. That just doesn't work. Okay, so I recognize this stuff does happen, so I will accept a few. So 2 late assignments is all that I will accept. Anything after that, you're just going to have to go without credit. So don't let yourself get too far behind. Okay. So let's talk about, well, actually, before I do that, do any of you guys have any questions? Let me throw it open to you. Before we start in talking about last night's homework, do any of you have any questions? I need somebody to respond, even if the answer is no. I need a couple responses. John's okay, Dan's is fine. Okay. All right. Once you see the quiz questions, what do you mean once you see the quiz questions? You should have seen them. Okay, well, tell you what, you're going to see them right now. Okay, so here's the first quiz question. All right, so this was just a conversion. Okay, yeah, once you see it again, okay. All right, so this one was just a conversion, making sure that you guys know how to do what I like to call the Ames method. Actually, I prefer to call it Hendricks method, but the other Ames teachers don't like that. So we'll call it the Ames method. Okay, so this one should have been trivial, I hope. Okay. If there's no questions, I'll move on to the next one. Okay, here's the second one. This one was also just a conversion question. So I'm hoping everybody's okay with that. And then the third one, again, also a conversion question. This time was a little bit trickier. This time, you may not have known what a microamp is, but now you do. A microamp is 1/1,000,000th of an amp. So there's 1,000,000 microamps in an amp. Okay, so you should be good with that. All right, so now we come to the first real question. All right, so voltage divider. Okay, so there's 2 places where we could put the photoresistor. We could put it up here at R1, or we could also put it down here at R2. And the behavior is going to be very different depending on where we are. Okay, so the question says that if you put it up here in place of R1, then should you write the code? Should you write the code in a way that triggers the buzzer when it sees the voltage go up, or should you trigger it when it sees the voltage go down? Okay. Tell you what, I'm interested in hearing what you guys say. Let's see a couple of people type in some answers here. Should you trigger it when it goes up or when it goes down? Or is it a trick question? North. Thank you, David. Okay, so it looks like everybody's saying up, and let's see what the answer is. Okay, well, first thing that I like to do before I decide the answer is I like to modify the drawing to put this mark here so that just to remind me which one is the photoresistor, because it helps me if I can see it. Okay, so now that I see that, I say, okay, so remember how photoresistors work. When they are in the darkness, they see more voltage, right? So if there's more voltage across this resistor, but the total voltage is fixed, that means there must be less voltage across this one. Okay, thanks, David. I appreciate the humor, but let's let it go now, okay? All right, so the correct answer is down, not up. So a lot of you guys there apparently still aren't quite getting it. So think about the way that I just explained it. So first off, take the drawing and modify the drawing so that it's very clear from the drawing which one is the photoresistor. And then remember that the way photoresistors work is that when it's dark, which is when the burglar is there, the resistance goes up, okay? So if the resistance goes up and the voltage across it is I times R, okay, then that means that the voltage across it is going to go up. And since we've got the output as being the other resistor, not the photoresistor, then it's going to go down. Okay, so you need to think about this a little bit more carefully. Okay, so now, what if in the previous problem, instead of putting the photoresistor in place of R1, we put it in R2? Then how does that affect things? Okay, so again, I like to look at the drawing. So here's the drawing, okay? And then I like to mark the drawing, showing me where the photoresistor is. So now we see the photoresistor is the one that's down here. Okay, so if the burglar comes and it gets dark, that means the resistance is going to go up, which means the voltage across it is going to go up. So that means that we have to write our Arduino code so it looks to see when the voltage goes up, not down. So the Arduino code has to be modified depending on whether you put the resistor up on top or down on bottom. Your code has to work differently if you put it in a different place. Okay, so now we've got a photoresistor and we have put it in place of R1. So it's up at the top here. And so I'm telling you what Vin is. It's 5 volts and R2 is 750. So if the burglar is not present, so it means if we are seeing light, or if the photoresistor is seeing light, okay? So we have to figure out what V out is. Okay, so I'm hoping that you guys got this one right. The answer is 3.3 volts, and here is a summary of how I got it. Okay, so I said, okay, if it's light, then the resistor is seeing 400 ohms. So the current is V. Oh, so Dan, is there a way to check your answers? Yeah, so I can go back and I can open them up, but actually you're checking your answers right now, right? I trust that you've got your notebooks out and you're taking notes. So right now is the time to check your answers. Okay. Okay. So anyway, so the current through the circuit is V divided by our total. All right, and our total is 400 plus 750. So 5 over 400 plus 750 gives us this number as the current. Okay, and so then we want to know what is the voltage across this resistor here, because this right here, you guys can all see, okay, good, you see my arrow. So this resistor right here is the one across which we're connecting our V out pins. So we need to know what is the voltage across this one. So when we do V equals IR, it has to be I times the resistor that we're interested in, which is R2, which is the 750. So we get 3.3 volts. All right. So I'm hoping that by now you guys are good with this. Okay. So question number 7. Same problem, same circuit, but what if the burglar is present? Okay, so again, I draw the picture. I indicate which one is the photoresistor. I do the math similar to what I did before, and I get an answer of 0.2. And again, this is how I did it. Exactly the same way I did before. Okay, the total current through the circuit is V over the total resistance, which is going to be different now. And so this is what I get for my current. And so the voltage across the resistor that I'm interested in. Okay, hang on a sec here. I've got too many things on my screen here. Let me see if I can. Yeah, all right. Okay, so the voltage across this guy right here, that's the one we want. So it works out to be 0.2. All right, so I'm trusting everybody's okay with that. All right, let's move on to the next one. All right, so again, I got too many people, too many things on my screen here. Okay, so again, what if we don't put the photoresistor in place of R1, but instead we put it in R2? What will the V out be if the burglar is not present? Okay, so same as before, here's the picture. I indicate on the picture which one's the photoresistor. Here's the math that I went through. Here's the answer. Okay. So I'm trusting everybody's okay with that. If anybody has any questions, speak up. Okay, I don't see any questions, so we'll move on then. Okay, question number 9. And this is the big one. This one summarizes everything that we've learned so far. So I made this one worth twice as many points as the others. Okay, so we've got a photoresistor, and we know how many ohms it has in the light, how many ohms in the dark. We put it in place of R1. Okay, so that means we want to modify the drawing to, and I can't emphasize this enough. Mark it on the drawing, because if you otherwise it gets confusing which resistor is where. So actually put it on the drawing there. Okay, so in this case, you've got a choice between two different resistors to use for R2. And so which one would be better and why? Okay, so what's the criteria for knowing which one is better? Okay, so Danny, yeah, I see that's one that you say is the better one, but why? What's the criteria? When you say that the 15,000 ohm resistor is the better one, what's your justification for saying that? The wider range. Okay, very good. That's exactly right. That's what we want to look at. We want the big range. Okay, good. All right, so here's what I did. Okay, so here are the numbers you can see here. So I calculated here that if we use the 150 ohm resistor, here I went through the math here, it's all shown here for you. So if the burglar is not present, we get 1.36 volts. If the burglar is present, we get 0.04. So the range there is 1.32. And then we say, okay, well, what if the resistor was 15,000 instead of 150? Go through the same math, and notice the numbers here are very, very different, and the range here is different. We get a range of 2.6 this time. Okay, so if we summarize it, with the 150 ohms, we get a range of 1.3. With 15,000, we get a range of 2.6. So that means that the 15,000 ohm resistor is the better one to use. And it all comes down to something called signal to noise. Okay, have you guys heard that? Those of you that are into ham radio, I'm sure you guys have heard it, signal to noise. All right, so if you look on the little picture here, okay, so this blue squiggle that you see, that's the noise, and there's always going to be some noise present. I mean, so imagine you've got the burglar alarm set up, all right? So the light sensor is seeing the light, but there's always going to be some fluctuations and the reason for it is complex. There's electromagnetic interference. We're bombarded right now. All sorts of things are happening in our houses around us and in the world around us that are causing electromagnetic interference. And so the signal that the Arduino is seeing is not going to be constant, even though the light you think is constant. The signal that the Arduino sees is not. There's going to be little up and down fluctuations due to all this electromagnetic interference noise that we're getting. And so what you need to make sure that the signal, which is the change in the reading once the burglar comes compared to when the burglar's not there, you need that signal to be bigger than the noise. And so that's why you want to use the resistor that gives you the biggest range, that gives you a bigger signal to noise ratio. Okay, any questions about that? Give me a thumbs up, thumbs down. Does anything about the quiz at all? Any questions that you guys want to ask before we move on to the new stuff? Thumbs up, no questions. Okay, good. All right. Okay, let's move on to the new stuff. All right, so here is today's assignment. We're going to put it all together. Now, if we were in the class, we would actually build a real photo circuit. And then I hope you guys are as bummed out about this as I am, the fact that we can't actually build it ourselves, because that's where the fun is actually putting the stuff together and see if it works. But what with this shutdown and all, that's just not an option. Okay, so what we're going to do is we're going to at least design it. All right, so use Tinkercad for robotics. Actually, we are going to be doing Tinkercad. Hold that thought. A couple of classes, we are going to do Tinkercad, okay, but not today. Okay, so here's the Arduino. Here is the voltage divider circuit. And let's say that we decide we want R1. That's the one that we're going to use as our photoresistor. So how do we hook it up? And what values do we use? Okay, so first thing I hope you guys realize is that the output from the voltage divider is going to be the input to the Arduino. All right, so the side here that is connected to the negative side of the battery, okay, right? So this is the side that's connected to the negative side of the battery. So that's what we call ground. So we need to run a wire from there into the pin that's labeled ground. There's actually 3 pins. You see right here where I've got the cursor, there's 2 pins there that are labeled ground, and then up here at the top, there's also one there. And those are all the same. It doesn't matter which one, any one of those 3 connected into that. Okay, then this middle line right here, that's the one that we want to connect into the analog pin of the Arduino. Now I've got it connected to A0, but it doesn't matter. You could A1, A2, A3, you know, any one of those 6 pins, A0 through A5, you can use any one of those pins. All right, so there. But what about the voltage source over here, this VN? Because a voltage divider only works if it has an input voltage. So where could we get the voltage from that? Do we need to have a separate battery? Or is there some way that we could not have to use a separate battery? I'm going to wait while you guys think. Where would you recommend that we get the voltage for our VN here? Somebody pipe up here. I'm going to wait until somebody says something. Breadboard? Okay, so Eve is suggesting we use the 5-volt pin, and that's exactly what we want. You see right here, where you see my cursor's there. So right there is a 5-volt pin. So the Arduino has this really neat feature where it always puts 5 volts on that pin, and it's always on. All right, so we can use that as the input for our voltage divider. Okay. Oh, before I get that, let me just make one little point here. I forgot to mention this. So if I go back up here, so if sometimes it's potentially confusing if we look right here where these 2 lines cross. Some people might look at that and think that those are electrically connected to each other. And so a good way to make sure that it's obvious that they are not electrically connected to each other is to do this little thing that I just did here, where the line comes here and it hops over. So now we know they're not electrically connected. But now let's get back to the question of where do we get the 5 volts from? Okay, so here's the answer right here. So we're going to run a wire from the 5 volts over here to this side right here of our voltage divider. And so there's our 5 volts. Okay, so if we got 5 volts up here, and this is ground, this is connected to ground, and ground by definition is always 0 volts. So that means that this intermediate lead here is going to be somewhere between 0 and 5. And what that exact value is will depend on the values of the resistors here. We could make that be anything we want, but it's always going to be between 0 and 5. It can never be more than 5. Okay, it's always going to be somewhere in between. Okay, all right, so now let's get into a problem here. So we know that the Arduino is going to be reading some voltage that's somewhere between 0 and 5. And we want to read what that voltage is, and then depending on what the voltage is, we need to decide whether to turn on the alarm, the buzzer or not. But there's a problem. Okay, the problem is that the Arduino, when we do analog read A0, which is the right way to get it to tell us what voltage it's reading, the Arduino is not going to give us the number of volts. The Arduino converts it into a different format. I like to call it Arduino units. I don't know if any other teacher calls them Arduino units, but that's what I call them, is Arduino units, right? So, so the way that the Arduino works is it will report a number. When we do analog read A0, it will report a number that's somewhere between 0 and 1023. So Dan's, you were exactly right. That is the range that it'll be. Okay. So if the A0 pin is seeing 5 volts, when we do analog read A0, the Arduino will report 1023. So if it was 2.5 volts, the Arduino would report a number that's half of that. Okay. And then for 4.2 volts, I have calculated that it would report an answer of 859. But how did I do that? How did I calculate for some intermediate number how many Arduino units is equal to how many volts? Well, the way that I like to think of it is, think of it as a unit conversion problem. Like those problems on the quiz where we had to convert units there. I just approach it the exact same way, okay? So Oh, let's see. Yeah, I forgot about this one. So one question that I figured you guys might possibly ask, and I'm actually a little disappointed that nobody's asked it yet. Why 1023? That's kind of a weird number, right? Why why would the range be from 0 to 1023? Why wouldn't it be like from 0 to 100 or 0 to 1,000 or something like that? Why 1023? Well, the answer is because computers work or think in binary, right? So when we're storing numbers in a computer, we have a bunch of little storage spaces that are called bits, and each bit can either be a 1 or a 0. It cannot be anything in between. So if you're using 1 bit to store your information, you can either store a 0 or 1, and that's it. But if you use 2 bits, so right over here, you see where the cursor is, you're using 2 bits, okay? Then you can, then you get 2, and then you get 4, and then so forth and so on. So with the number of bits that the Arduino is using, when it stores a number, that number that it stores can be anywhere. There are 1,024 different numbers that you could store. Now, if you start counting at 0, that means that the highest number that you could store is 1023. Okay, so that's the reason why the Arduino chooses that particular number. Okay, so here is, let's see, I've got too many things on my screen again. I really should get rid. Okay, so here's a question for you guys. I want everybody to think about it, and I want you to type your answers into the box here. So if 5 volts is the equivalent of 1,023 Arduino units, how many Arduino units would 2.9 volts be? Think of it as a unit conversion problem. I'm going to sit here quietly and wait. Okay, so Luke is saying 593. Does anybody second that motion? Anybody opposed? We can't move on until somebody seconds the motion or somebody says, no, Luke is wrong. We're not going to move on until somebody says something. Okay, Luke is maybe right. Sorry. Okay, so Eve is seconding it. Okay, right. Oh, so Danny is taking it even further. Danny is saying that it's not just 593. It's actually 593.34. Okay, so let's see. So here's the way that I recommend everybody do this. Remember this screen that you're seeing right now. This is what I like to call the Hendricks method, but the other Ames teachers forced me to call it the Ames method. And the other teachers who are not at Ames, teachers at other schools, they get grumpy too because they say, hey, this is our method too. But I'm going to call it the Ames method. All right. So step number 1 of the Ames method, write down the unit, write down the number together with the units. If you don't write the units down, it's not the Ames method. Okay. So there, what you see here is 2.9, and notice I included the units. I included the V there. All right. So we've done step 1. So now step number 2 says write down the conversion factor. All right. So what is the conversion factor? Well, here's the conversion factor. You know that 5 volts is equal to 1023 Arduino units. Now I'm calling it an AU. Now, if any of you are into astronomy, you might object to me calling it an AU because astronomers have already taken that term. An astronomer says that an AU is an astronomical unit, which is the distance from the sun to the earth. So the earth is 1 AU away from the sun. Venus is about 0.7 AUs away from the sun. But in this class, I'm going to use the term AU to mean Arduino units. Okay, so that's our conversion factor. So now we go to the next step in the Ames method. So now it says we need to write some parentheses in a horizontal line. So, okay, I can do that. There we go. There's our parentheses in the horizontal line. Okay, what's the next step? Well, the next step is to take the numbers from our conversion factor and put them into these spaces that we just created. So one of them goes on top, one of them goes on bottom. All right. Now, if we've got volts here and volts is what we want to cancel out, then what we should do is whichever one of these has the volts in it, that one goes on the bottom in order for it to cancel out. The other one goes up on top. Okay, so when we put them in, there we go. We put them in that way. All right. Now, The next step is one that people quite often forget. And the next step is one that I insist you have to do, and that's cross out the units. So notice V on top, V on bottom, they cancel each other out. And the reason this is so important is because if you're not careful, it's very easy to get these numbers mixed up. Instead of putting the 5 volts on the bottom like you're supposed to, it could be that you put it up on the top, right? And then when you go to cross out the units, you'll see, uh-oh, they don't cross out. You got volts on top, they don't cancel out, okay? So crossing out the units is an important part of the Ames method, okay? Don't forget that. All right, so now we see that the units have canceled out like we wanted. Okay, so now we can go ahead, we can do the calculations, and we get the numbers, and we do in fact get 593.34, exactly like Danny said. But the Arduino works in integers. Okay, so the Arduino is going to truncate that, and it's going to report the number as 593, not 593.34. All right, so now we know the answer there. Okay, so now we know that if there was 2.9 volts on pin A0, when we write our code where we say analog read A0, the Arduino will report that back as 593. Okay, so then when we write our burglar alarm code, what we need to do is we need to either we need to set a threshold, and I recommend that you don't set your threshold right at 593. You want to put it a little bit above or a little bit below, or maybe a lot above, a lot below, okay? So that you don't get false alarms. And depending on where you put the photoresistor, you are going to have to write your Arduino code so that it either triggers when it goes up or whether when it goes down. Okay. All right. So here's the homework. Today's lecture session is going to be pretty short here, I think. I didn't want to overwhelm you with too much homework. So you only have one homework problem today. This is it. Okay. So what you see here is the layout that I want you to use. Okay. And notice where the photoresistor is. The photoresistor is up here on the upper resistor now. Okay, so if you hook up your circuit like that, then I want you to write the Arduino code for the burglar alarm. Now, another thing that's really important is that the photoresistors, they have slightly different values. In last night's homework, I told you a set of numbers. I said that if the photoresistor is in light, then it gets this many volts, and if it's in darkness, it gets that, or this many ohms, and if it's in darkness, it gets that many ohms. You're going to notice that the numbers that I have up here are different this time, because even if you buy 2 photoresistors at the same time from the same manufacturer, and they are supposedly exactly the same, they never exactly are. Okay, they're always, the 2 photoresistors, even though they're both seeing exactly the same amount of light, they're both going to have slightly different resistances. That's just the nature of how it works. You can't get around it. Okay, so we've got a slightly different photoresistor today than we did before. In this photoresistor, okay, when the photoresistor is seeing light, then it has 520 ohms of resistance, which is different than last time. And this time when it's in the darkness, then it's seeing 1,400 ohms, okay, which is actually quite dramatically, wait a minute, 1,400, that's not what I intended. I'm going to count that as a typo. Hang on, let me go in and fix that. Whoops, let me go back here. I had not, 1,400 is not realistic. That should have been 14,000. Zero there. Okay. All right, sorry about that. Okay, so because that, yeah, 1,400, that's not a realistic number. 14,000 is a much more realistic number. Okay, so that's the value that I want you to use. Let me come back to, well, let's see, what did I do in the next slide? Did I put it in the wrong way in the next slide too? Okay. All right. So when you're doing tonight's homework problem, the first thing you need to ask yourself is, how should you write the Arduino code? Should you write the Arduino code so that it turns on the buzzer if analog read A0 turns out to be less than some number? Or should you write your code so that it turns on the burglar alarm if analog read 0 turns out to be greater than some number? Okay, so that's the first question you need to ask yourself. And then the second question you need to ask yourself is, what number is it? What number should you put in the code so that if analog read A0 either goes up or goes above or below that number, then that's when you turn on the buzzer. So those are the two questions that you need to ask yourself before you get into it. Okay. And oh, it looks like I did in fact make it wrong down here. Let me fix that. Okay. So Danny is asking if there's specifically a time in which the burglar alarm should buzz. So thank you, Danny. I did anticipate that question. And so what I did here was I wrote your functional specification for you. Normally I wouldn't do this, but you know, well, with this remote class. Okay, so here is what I want you to do. So I've written the functional specification for you. Here it is. So when you first turn on the Arduino, okay, I want you to give me some sort of a feedback to let me know that the program is in there, the program's alive, the program's working. And the good way to do that is give me this little countdown. That's just, it gives me a nice warm fuzzy feeling that I know that the Arduino is working right. Okay, so when you first turn on the Arduino, I want the built-in LED to flash 5 times, and then pause, and then 4 times, and then pause, and then 3 times, and then 2 times, and 1 time. So it's a countdown. And then after the countdown is finished, then the Arduino goes into the mode where it watches for the burglar. Okay, so if the burglar comes, so in other words, if the photoresistor sees darkness, okay, then I want you to write your code so that it turns on pin 7. And the understanding, which I did not include in the picture here, but the understanding is that pin 7, we're going to connect that up to a buzzer. Or, you know, we'll connect it up to some automatic phone line that phones the police or something. Okay, so pin 7 is what we want to turn on if the burglar is there. Okay, so we're going to assume that we got it connected to a buzzer. And so in answer to your question, Danny, yes, I want that buzzer to buzz for 60 seconds. And then at the end of that 60 seconds, I want the Arduino to look again. Okay? I want the Arduino to look a second time and see if the burglar is still there, then it activates the buzzer for another 60 seconds, and it just keeps repeating that forever. So as long as the burglar is there, the buzzer is going to buzz. And so hopefully eventually the burglar is going to get so annoyed with the buzzer that he'll leave, or she, okay, will leave. All right. And so then after the 60 seconds has elapsed, if the burglar is not there anymore, then I want to turn off the buzzer because I don't want to annoy my neighbors too much. Okay. But if the burglar comes back, I want that buzzer to come back on again for another 60 seconds. All right. So the first step here, this little countdown that we do that once and only once when we turn on the Arduino, and then we never do it again. And then these other steps down here, those are the ones that we just repeat forever and ever and ever and ever. All right, so that is your homework. And by the way, this is not just a regular homework assignment. This is the midterm exam. So remember how it works in this class is that the midterm exam is that we build some device. Well, unfortunately, we can't actually build it because of the Corona shutdown, but we can certainly design it. And so this is not just a regular homework assignment. This is a midterm exam. So make sure you do it carefully, do it right. It's going to be due at the beginning of class next time we meet, so you got 2 whole days to do it. There's only one question, and that's this, but there's several different parts. So remember, you've got to figure out what number to put in your code so that when you do analog read A0, okay, if the number that you get is not the right number, you want to set off the alarm. So you need to decide, are you going to set off the alarm when analog read 0 goes above some threshold, or are you going to set it when it goes below the threshold? And you need to decide what that threshold is. So you're going to have to do the math. you're going to have to set up the voltage divider and calculate what voltage is the Arduino going to see when the burglar is not present, what voltage is the Arduino going to see when the burglar is present, and then somewhere in between there, you're going to pick, okay, that's what I'm going to use for the threshold. So I think I've explained it pretty thoroughly. Does anybody have any question? If you don't have a question, can you just type in and say, yep, it's clear? Okay, so Aaron said no questions. Yes, it's clear. Okay, I'll just let me just wait for a couple more. Okay, other people are saying that's clear. Okay, good. All right, so that's it. That's your one and only homework assignment. So unless anybody has any questions, I'm going to turn off the recording and stop the meeting, but I'll give you a few seconds. So are there any more questions before I conclude? Okay, so Dan is asking when it's due, or Dan's is asking when it's due. And the answer is at the beginning of class next time we meet. So like 11 o'clock on Friday, or maybe I might put it as 10:59. At 10:59 a.m. on Friday when it's due. Should you add pin mode 7? Absolutely, yes. Okay, remember your code has to have two parts. It has to be a setup and it has to have a void loop. So if you're going to use pin 7, which you obviously have to, you darn well better, yes, you better say pin mode and the appropriate pin mode for pin 7. And also remember you're flashing the built-in LED. So that means you're going to have to do pin mode for that one as well. Anybody remember which pin is the built-in LED? Is that pin 1? Is that pin 11? Which pin is that? 13. Okay, very good. All right, glad to see that. Okay, so last chance for questions. Going once. Going twice. Okay, sold. Okay, I am going to stop the recording and I'm going to end the meeting.